so yeah, we learned about lists, and we learned about the like very basic idea of a list. If we return a generic type from an object, can you store it in a variable of the same type you have set the generic as? I'm not sure what you mean. So like if you push something of type T and then you pop something of type T, like when you create an instance of your thing that's generic, you specify the type, right? When you create it. So like in your code, like you might have like, okay, I'm making a stack of type int. If you pop something, like, I mean, you know that it's going to be an integer because you created the instance of type int. I'm not sure if that answered your question. You might also be thinking too hard, where your concern might not pop up. I mean, it might pop up if you have like, if t is an int and we store it in an int variable. Yes, that's correct. But of course, if you have like a node that is used to make like a linked list, for example, like you can like send the generics down all the way to like the smallest class in what you're doing. So like your nodes will store the data of type T, and then maybe in your linked list you add something of type T, but the T is going to be the same between the lists and the nodes. So yeah. So we were learning about the high level basic parent class list. And all lists are going to be similar because we talked about different types of lists. We talked about ordered lists, unordered lists, and index lists. And index lists are like the Python lists that we were used to last semester. All of these lists have a lot in common, but they start to get a little bit different once we start worrying about like how are we going to add something? And the way we add something is it's going to depend on the type of list, like an ordered list. Well, if we add something, the order needs to be preserved. And that's what we had started looking at. So if we go here, so yeah, array list, and then here I'm making an ordered list. So all I'm doing is like I'm hijacking the array list, inheriting from it. I've got no other extra private attributes. I've got my constructors and I have my add. The constructors, I'm just going to hijack the parent class's constructors and deconstructor. Nothing fancy there. It's just the add that's going to be a little bit different. And all we did was this part here is, okay, if we're out of room, we expand capacity. And we'll expand capacity before we ever try to add anything. That's important. And this is the same as like the stacks and the queues. Then we start this part. And this is basically the linear search for where does the thing element, where does it belong in this list? So this will search until it finds the spot where it belongs. Then we make room for it by shifting everything up starting at that index. So everything moves up an index. And then we insert the actual element we're trying to add into the appropriate spot. Basically, we have an array. And we've got like A, B, C, D, E. If I want to insert something where C is, well, I'm going to have to move E down, move D down, move C down, and then add element here. That's supposed to be element. So there's the shift up. So if we're out of room, expand. Otherwise, search for where it belongs, make room for it, and then add it. That's all. Again, I know last time I said it looks a little bit more complex, but if you break it down into what the pieces are doing, it's not too bad. Yeah, we need this because we use the this to access the protected stuff. So that's it. That's all we need for the ordered list. Everything else we needed came from the base class. And if we go here and we look at array ordered list, I mean that's all I have. I've got, okay, it's generic, so everything's in the header. So we define the template stuff. Nothing. The constructors, those just hijack the parents. And otherwise it's just the add. Then I can implement, in fact, let's do this real quick. So I guess I'm gonna have to inherit. Array ordered list. Okay. In fact, I'm gonna also include list. QRS. I like to put my imports in alphabetical order. I don't know why. It's probably not even a good idea in this case, but whatever. Include list. Okay. Now down here, I'm going to make a, and I mean, you may remember, I can do this. A list of type int. Oop. Array list. Yeah, that's supposed to be array list. There. Equals a new, oh, my goodness. Remember, I like my pointers. Equals new array list. Oh, array ordered list. Oh, and I guess I need a name, my list. Then here I can just say, all right, so my list dot add. And what am I going to add? I guess I'm gonna add, I mean, they're gonna be integers. So like, I'm gonna add 5. What's it gonna complain about? Expression must have class type. Oh, I have this backwards, my goodness. Wait, what's the dash? I don't know what that means. Oh, you mean this. Well, still, I think it's mad because I've got this backwards. Remember, the child class, so I'm gonna make it this way. Only things that exist in the parent class can be called for sure safely. So I've fixed it by doing it this way. My list, add 66, and then my list, add 3. And if everything worked right, I should be able to, so what do I have in my regular old array list? So I've got size capacity list. Those are the protected things. Shift up, find. Remove, here's what I'm gonna do. I'm gonna call remove first, remove first, remove first. And we'll see the order in which things come out. So actually, here, I'll do this. While my list is empty, not std cout my list remove first. And if everything worked properly, we should see 3, 5, 66, right? Build it. Uh-oh, something failed. Exception, oh man. All right, so where was this one angry about? Well, not in course, I don't care about that. All right, well, we fixed this last time, I think. Header. What was it? STD exception. I wonder if, you know what? Easiest way to fix it. Who remembers what it was? I heard a boop. IOStream fixes it, I think. Yeah, you're probably right because that's another one. So let's just, well, it should be, you know what? For ease, I'm just gonna comment them out. It's the easiest thing to do without getting messed up. Wouldn't it be not? Yeah, you're totally right about that. You're totally right about that. There, I think, yeah, this'll, there we go. I think that'll do the trick. So I could probably put this one back in. But I think Johannes was right about, like, other things from the standard library might include this without issue. That's why before we didn't have to include them. Okay, let's try again. Generating code, okay. So cross your fingers, 3, 5, 66. Yay, it worked. Is that a surprise? No, but it's neat though, like our ordered list. Now I'm guaranteed to have the right order. I mean, you might even, well, no, I won't say anything more about that. Cool. So now let's make an unordered list. So an array unordered list, what are we gonna want? Well, okay, it'll be generic. We'll inherit from array list. Nothing extra. And then we'll have our constructors. And then we only had the 3 different adds, right? We had the add to front, add to rear, add after. So add to front should be pretty easy. All we have to do is check if if we have space. Otherwise, shift everyone down 1 and then put the thing at index 0. Add to rear is just add it to the rear, but of course we got to check if we need to expand capacity. And then add after, check if we expand capacity, do a linear search for the target, and then do the shift and whatnot. So add after is going to be a lot like the ordered lists add, except here we're not looking for the less than greater than. We're just looking for, well, which one do I want to add the thing after? So let's go here. Add class array unordered list. I won't even add the base class because when I copy and paste, I'll have that already. Okay, so we need our constructors. I'm just gonna hijack what we already had from the parent class. Nothing extra fancy needs to be done. Okay, then we've got our 3 adds. So add to front. Well, here, let's copy this over and then we'll have a look at what the code is doing. All right, what are we doing? Add to front. Well, it's going to take the element t. If we have to expand capacity, do it. Otherwise, shift everyone starting at 0 up and then add element to index 0. Increase size. That's it. So, I mean, that's awesome. That's nice and easy. Add to rear might even be easier because we don't even need to do any shifts. All we have to do is check, do we need to expand capacity? Otherwise, add it to size and then increase size. This is kind of like push for an array stack, right? So that's pretty handy. We just needed this because, you know, that's from the parent class and they're protected. And I guess add after is going to be the more complex one, but again, shouldn't be too bad. So let's have a look. Nope, wrong button. Okay. All right. Oh, look at this. This is awesome. I don't even need to do anything special here because I already have the function find, which will return the index of where the specific thing is. And we implemented that. Right here. This does the linear search for us. So I'm just hijacking something from the parent class again, which is awesome. I guess I'll do standard exception to make it stop complaining. Did I not? Whatever. Yeah, so add after, just find the target we're looking for. If index isn't -1, because remember, find returns -1 if, oh, I guess I gotta go back to lists. Yeah, find returns -1 only if we don't find the thing we're looking for. So, yeah, if index is -1, okay, now we know like the thing's not there, so we'll throw the exception. Otherwise, well, do we need to expand capacity? If we do, do it. Otherwise, shift everything up starting at index +1 because we're adding after now. Where before when we did the insert or when we did the add for the ordered list, we wanted, like we found where it would go before. So we had to move everyone, including this. Here, let me paint. When we had the ordered list, if I had like 1, 7, 13, 14, and I wanted to add 8, I would go, okay, does it go here? Does it go here? Does it go here? And then I would go, oh, okay, so now I need to move everyone down, including this one. In fact, let me just double check to make sure that is how I did it. Yeah, so we have to move everyone down, including this one with the ordered list. But because in our case, with the unordered list, we're saying add after. So if we have like A, B, C, D, and I determine I want to add after this, well, I want to leave this index alone and then start shifting everyone down from index +1. So that's why that's there, if you were a little thrown off. Otherwise, shift everyone down 1, insert the thing at index +1, increase size. That's it. So that's pretty easy. So yeah, unlike the ordered list, like that's it. All we had to do was add the ads. And now we have array index list. So this one's a little bit more complex, but we're gonna see some neat stuff in here too. None of this should scare you, but perhaps this thing down here at the bottom will throw you off a little bit, but it's actually really cool. And we can kind of do this in Python as well, but whatever. I'm gonna show you this, and it's good. It's really cool. All right, so first, let's create our indexed list. So add class array indexed list. Okay, I'm gonna go here. Go here. All right, so what are we gonna have? Well, nothing new here. Our constructors, no big deal. Add, set, get, index of, remove, and then this fancy thing that we'll talk about. All right, well, suppose to get started, let's get our constructors. Again, nothing new, just hijack the parent classes. Okay, then what do we have? All right, so we need to have our add. So add, there's two adds. It's an overloaded method. So if we call add and we give it an integer and something of type t, that means add something at a specific index. What are we gonna do? Well, okay, so if we have to expand capacity, do it. Otherwise, shift up from that index, because if we wanna add something at a specific index, then we wanna move everyone down. So shift up from the index, put the thing at index into element size ++. Okay, great. We've got another one here, a regular add. It looks like this add, the one that doesn't take an index. So this is the overloaded add. We've got add, one that takes two parameters, an integer and something of type t, and then an add that just takes something of type t. So if we ever call add without specifying the index, we just append it to the end. Because why not? I mean, I guess you might say, well, why not append it to the beginning? Fine, but I'm deciding to do it at the end because to me that makes more sense. Set. So set is going to be, well, basically go to something at a specific index and set it to that thing that we want to make, that at that index. Blech. There. So basically overwrite whatever was at that index. Now here I've just got some error checking stuff. If index is less than 0 or greater than or equal to the size, I'm going to throw an exception. I mean, this kind of makes sense, right? Like, and you might ask, well, why not do this like up here? If we add something at a specific index, why not, like if you specified an index that wasn't safe, you should throw an exception. And you know what? You're absolutely right. So I'm going to go here. And I'll just say that again, just in case, because I did say it quickly. If the individual that calls add, or down here, set, specifies an index that is less than 0 or greater than or equal to the size, the index is out of bounds, right? Like, if I have an array of size, like 15, and I try to index 5 billion, that's problematic, right? Like, we're out of bounds. There's only really 5 things in there. So if the index is safe only, then we're going to set the thing at that index to element, effectively overwriting what was ever in there. Whatever was in there. Tongue-tied. Get, same idea, just easier. Specify the index, return the thing at that index. Again, check if we're actually in a safe boundary. Index of, so index of, it's basically find. Find something here, find an element. If it doesn't exist, return an exception. Otherwise, return the index. Again, here you might say, well, you know, if I ask for the index of something and it doesn't exist, maybe I shouldn't, maybe I really shouldn't be throwing an exception, maybe I should just like return -1, right? Like just, okay, if I ever call index of on a list and it returns -1, I'll know that I didn't find it. And you know what? Fine. That is a fair and reasonable idea. But I'll make it so we throw an exception because why not? You'll see I'm saying a lot of like, well, why did I design it this way? Well, I guess I could have done it that way, but I did it this way because why not? If it wasn't obvious, we're now at the point where we're programming and we're solving problems, we're building data structures where we have choices to make, and ultimately at the end of the day, it doesn't matter too much. I know I was saying since the beginning of 161, like how many ways are there to solve a given problem? And the answer is literally an infinite number of ways. But that feels kind of like an infinite number of ways. But we're at the point now where if it wasn't obvious already, it's becoming obvious that, oh, I can kind of now see what he means when he's saying like, oh, there's more than one way to solve this problem. Like I've got a lot of choices to make and it doesn't really matter at the end of the day. I mean, there might be some engineering paradigms and rules of thumb, for lack of a better word, that one could follow, but really doesn't matter. From the pure computer science perspective, at least. Remove. Okay, remove something at a specific index. All right, check if the index is in bounds. Otherwise, take the thing from that index, shift down to that index, effectively removing whatever was there, and decrease the size and return element. Why is remove returning an element? Well, because if you just wanted to remove something from the list and you didn't care what was actually in there, well then ignore what it's returning. But maybe you care about actually removing it from the list, but keeping it to do something with later. That's why we return the element. Now, before I get to the operator bit, are there any questions about what we've seen so far? Because I moved quickly, I'll admit that, but really it's because everything was so similar and all the functions we were writing shouldn't have been overly terrifying because it's just more of the same. Adding things, removing things, hijacking other functions that do half the work for us, shifting things up, shifting things down, right? So it's funny because we might be at the point too in the class where you're thinking to yourself, man, how many more times are we going to do a linear search? How many more times are we going to be moving things down an array or moving things up an array? How many times are we going to iterate over some sort of collection? How many times blah, 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 blah. Yeah, you're right. And these, like if you think back, like if you were with me in 161, if you think back and how much I talked about linear searches that you were probably thinking like, okay, well, hopefully now it's very obvious why I talk about linear searches. These linear operations of like moving down, moving up, shifting things, very common. Very, very, very common. So no questions though. So no, everyone's A-okay with what we've seen so far. Okay, all right, okay, fantastic. All right, so now for the interesting one. That's not what I intended. So, what I'm saying here is, you'll see this is very similar to get, all right? Very, 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 very similar to get. Okay, I'm checking if we're out of bounds, otherwise return the thing at the specified index. Check if it's out of bounds, otherwise return the thing at the specific index. In fact, it's not even that it's very similar to get, it is identical to get. In fact, I could replace all this with this. There. This will do the trick. Now, what does this mean? All right. It's a template class. And then what is this function going to return? It's going to return a reference return a reference, not a pointer, a reference to something of type T. And when I specify operator, open bracket and close bracket, what I'm saying is I'm defining what it means to use square brackets on some collection of things. I'll show you what I mean, because this will probably make a lot more sense if I show you. So I'm gonna go here. I don't want an array ordered list. Array indexed. Oh, I'm gonna have to array index IJKL. Indexed list. I heard a boop. What do we got? Wait, so can we do that with any operator? I mean, there are, yep, you can do it. You can define plus for this to effectively be add at the end. In fact, we will do that just for fun. Even though I didn't include it, we'll do that and we'll have a look. And here, look. CPP operator overloading. Let's see if we can have a look at what our options are. So, let's see. We've got operator at equals. I guess that's an assignment. Operator parentheses, square brackets, arrow, and I mean, there's got to be more than this. Like we can define less than, we can define greater than, we can define like less than, I believe. We can define plus, struct sum, increment, decrement. Okay, operator plus equals. Okay, hold on. I don't like this one. What do we got here? Operator overriding in C++. Let's see if we can find a better list of our options. What? Why am I having such a hard time finding just a list of overridable operators? So, okay, operator plus. Here we go. Overloadable slash non-overloadable. Here we go. So we can do plus, we can do and, we can do less than, we can do less than, we can do plus equals or equals. The little arrow, a dash, or minus, pipe, greater than, blah, blah, blah. This is everything we can do. We can overload all these things. We can't overload colon, star, dot, or question mark, colon. So I am a particular fan of this one for our lists. So array indexed list, new array indexed list. So if I go back to array indexed list, set, add. Okay, I'm just gonna add things. Just like I did here. But then at the end, I'm gonna add 30, but I'm gonna add it at index 1. So if I do the remove firsts, I should see 5, 1, 66, and 3. Because otherwise, add without specifying the index is like appending to the end. Oh, what did I forget? Syntax error. There. So 5, 30, 66, 3. So we know that everything there is working. But check this out. What if let me get rid of this. No. Nah. For int I equals 0, I is less than my list size, I plus plus. Okay. Except instead of removing the things, I'm going to leave them there. But look, I'm going to index this. I'm going to do this. Why is this not working now? Because it's a pointer. I got to dereference it. Do I have to dereference it like this first? Okay, well now what am I doing wrong? I'm making a liar of myself. No operator star matches these operands. Oh, because I have to do this. There we go. So because this is a pointer, I have to dereference it first. Cannot convert something of type T to T ampersand. What? My goodness, now I'm merely making a fool of myself. What am I doing wrong? I always forget this. Not really seeing. Cannot convert T to T ampersand. That is something of type T. So how do I make this the reference again? Because should I make the reference variable first? T reference called to ret equals this get I. Ugh. And then let's call this to ret. See if this shuts it up. If not, otherwise I've messed up. Now what am I initializing? Cannot convert T to T ampersand. What am I doing wrong here? I can't get the memory address of it. I just assign this to something of a specific type, right? This get I isn't an address. Yeah, but it's not, remember, it's not a pointer, right? The ampersand means it's cold. Yeah, maybe you're right. Do I do the, I think you're right. Is this it? No, that's to get the memory address of. My goodness, what am I doing wrong here? Yeah, because to return, this gives me the T, right? But if I want to make something of type T amp to make a reference, here, let's just make sure I'm not going crazy. And look, you remember me saying I'm not a C++ programmer. So if I do int ASD equals 5, and then I do int ampersand QWE equals ASD, this works, right? And then I'll print this out just to make sure. QWE. And then I'll just not do this currently. Yeah, so that should be fine. No, need to put the ampersand before ASD? Wait, no, need to put the ampersand before ASD. Yeah, no, but the ampersand before ASD would return the memory address of it. Is get returning T instead of T? Well, yeah, it is returning something of type T, but we can assign something of type T, right? So ASD is type T, but we can assign something of type T to a reference of that same type. Oh, guess so. Yeah, I don't know. What am I doing wrong here? It's probably something stupid that I'm just forgetting. All right, so maybe this will work just fine. Even though before get, do I have to cast it as? Okay, so here's what I'm gonna do. I'm just gonna replace it with the old version. Nope, no. There. What? Okay, probably because get did return something of type T, and it was too stupid to know that the thing of type T could automatically be a reference to type T. But when I type literally the exact same code of what get is doing here, it works just fine. What? Okay, so just, yes, exactly. Weird is right. Well, whatever. There we go. To be fair, very confusing. Will we have to implement this? I don't think so. Long story short, if you don't get fancy and try to hijack the already existing functions, which is arguably the right thing to do, it'll be fine. Here, I'm wondering, what if I do like T ampersand? What if I cast it and just tell it like, yeah, shut up, I know. No, all right, yeah. Illegal use of this type in an expression. Yeah, okay. Because this is me trying to get fancy. I guess the rule is if you're doing it and you're calling a function that returns something of type T, it can get confused. There's probably a very good reason why. Don't ask me. And Alex said it just right. Just C++ things. Yep. Okay, so now for the fun of it, let's do a reference. So how should I do plus? What am I going to want plus to do? Okay, how about this? I'm going to have plus work where operator plus, its return type, so let's have a look. Does it have to return something? Plus, okay. See if I can get plus working. If I can't get it working quickly, whatever, I'll give up. And this is gonna have to return an array list, an array indexed list. Does it have to be a reference? I'm wondering. Constant indexed list. How did we write it here? Array. Why is there no B? Okay, so it has to return something of type B. It's going to take a constant array index list reference A. Okay, and now this is angry because it's not defined in the header, I believe. Oh, no. There. It's going to return the new one. Yes. Okay. So what I'm going to do is define the plus to be concatenate. If I ever call plus, it's going to take this array list, and concatenate the two. So how am I going to do this? Now what's it upset about? Argument list for, of type T. That. If I go back up here, I probably have to say type T. Yes. Okay. So I'm going to want it to basically act exactly how it should in Python. So what I'll do is I'll make a new array indexed list. And I'll want it to be, if I'm having it return that, how do I want to do this? Do I want to make it a, no, I guess not. No, it will have to be. So let's say array indexed list of type T pointer, pointer, my goodness. Cat list for the concatenated one equals a new array indexed list of type T. Then all I'm gonna do is go through this lists and add them, and then this list and add them. Okay, yeah. So for, in fact, do I have anything special in here that might speed this up? Expand shift, array, remove first last, contains is empty size. No, okay. Did I hear boop? No, okay. All right, so for int I equals 0, I is less than, I is less than this size, I plus plus. Then what I'm going to do is I'm going to say cat list add this, get the thing at location I. Okay. Then I'm going to do the exact same thing here and say, except instead of this, it'll be, what did I call it? A? A dot get. And then this needs to return that, so I'll do return the dereferenced cat list. So what am I doing? Basically, create a new list, put everything from the old list in it. How? We'll just loop over everything. Take everything from the other one here. This would be like the right-hand side of the addition. And then add it to cat list, and then return cat list, but the actual dereferenced thing. So if we go here, my list 2 equals, actually, I should be able to do this, right? My list right, that should work. So I just basically have another Lou list. That's a copy of this one, which we know is 530.66.3. Then, oh, actually, no, I'm gonna want this again. Now I'll make another one to be this. My 3 equals my list plus my list 2. But I think this will be mad because I'm gonna have to dereference these things. What am I doing wrong now? This will teach me for trying to be all fancy. It's because it's a pointer. Oh, okay. So I'll need the memory address of everything here. Is that all it was mad about? Too many buttons. And I think I can get away with this. Nope, no, but this one definitely needs to be dereferenced. Yeah, okay. So all I did is take the dereferenced my list, the dereferenced other one, added them together, and then because the addition returns an actual array list, well, I want the memory address of it because I'm going to put it into a pointer. And here, I'm just going to say my list 3. And if everything works properly, which it very well may not be working properly, I should see 530.66.3, 530.66.3. Right? What am I doing wrong? Missing that before that? Oh. All right. That's an easy fix. Oh, now what am I wrong? Oh my goodness. Size. A get size. Int array list at its size cannot convert this pointer from constant to array list of ampersand. What? And get, add. So what am I doing wrong here? But it is int array cannot convert this pointer from const array ampersand. See, now it's a damn reference issue again. But if A is a reference, well, I'm not sure what it's angry about at this stage. Looks like something here, but why? Array indexed list size. It returns an integer. Int array list size cannot convert this pointer from constant array to that. Let's go look at the copy constructor in array list to see if there's anything obvious that I'm missing. And if any of you see anything obvious that I'm missing, let me know. Ampersand. Why don't you just return cat list? Because it already has. Because I think so. You raise an interesting question, but I have a feeling that when we implement the operator, it has to return something of this type. Because if you're adding like an integer and an integer together, it needs to return an integer. So if I make it return an integer pointer, I think it's going to be angry. So I think it's just like the magic code we need. Is it? No. Array list. So why is it happy to do object size? But here it is not. I'm pretty sure get will return a copy of the value instead of a reference to the value in memory, since get returns t instead of that. And then if add takes as a parameter, then it thinks it might be. But t ampersand, like a reference to t, that shouldn't matter because, I mean, you might be right because we definitely ran into this issue of pointers and whatnot with like pointers, references, blah, 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 like we did with this one right here. So, and but it's only angry here. All right, well, either way, I'll see if I can fix it before next class and see if it's anything. It's going to be something silly that I got to fix, and you may very well be right, Gabe. But anyways, other than that, we'll wrap up here, and wish me luck on getting this one figured out.